Quantum mechanics and relativity cannot both hold inside a black hole. Inside a black hole, one of them must die, or both must die. There are three irreconcilable conflicts between quantum mechanics and relativity inside a black hole. The first conflict is the black hole information paradox. Suppose there are three completely identical black holes. We throw 100 kilograms of soccer balls into the first one, 100 kilograms of bread into the second, and 100 kilograms of books into the third. Are these three black holes still completely identical? Hawking calculated, based on general relativity, that a black hole has only three basic properties: mass, charge, and angular momentum. Since all three black holes have the same mass, carry no charge, and have no angular momentum, general relativity concludes that these three black holes are still exactly the same. However, quantum mechanics disagrees. Quantum mechanics has a fundamental assumption. For a system that does not exchange matter or energy with the outside world, all microscopic physical information in its evolution is not lost. In other words, information is conserved. Soccer balls, bread, and books carry different information when they enter a black hole. Based on the principle of information conservation, the final states of these three black holes must be different. General relativity says the three black holes are identical. Quantum mechanics says they are not. And that is the contradiction. This is the famous black hole information paradox. Hawking proposed this paradox in 1975, and nearly 50 years have passed since then. Physicists have published more than 7,000 academic papers around this paradox, and it still has not been fully resolved. The current mainstream view tends to support quantum mechanics, arguing that information must be conserved, and therefore the three black holes cannot be identical. Next comes the second conflict between quantum mechanics and relativity, the black hole firewall paradox. This paradox occurs at the black hole's event horizon. So let's first briefly explain what an event horizon is. Anyone who often hangs around black holes probably knows this. Once an object gets close enough to a black hole, it can no longer escape. For a black hole with 10 times the mass of the Sun, this distance is about 30 kilometers. Even light, the fastest thing in the universe, cannot escape once it is within 30 kilometers of the black hole's center. This spherical surface with a radius of 30 kilometers is called the event horizon of the black hole. Simply put, the event horizon is a one-way demon. Things go in, nothing comes out. It only eats, it never spits. The event horizon has another remarkable property. From the perspective of a distant observer, the closer you get to the event horizon, the slower time flows. At the event horizon itself, time appears to stop. You jump into a black hole holding a soccer ball and wearing a wristwatch. Telescopes on Earth will see you and the ball frozen forever at the edge of the black hole. Even after 100 million years, the image will not change. But from your own perspective, your watch ticks for only 60 seconds. You feel as if you held the soccer ball for just 1 minute, while on Earth, 100 million years may have passed. Now let's talk about the black hole firewall paradox. This paradox is very difficult to understand. If you don't get it, that's perfectly fine, it won't affect what comes next. Suppose particles A and B were originally quantum entangled. Particle A remains outside the black hole, while particle B falls into the black hole. According to the equivalence principle of general relativity, to maintain the smoothness of the event horizon, particles A and B must remain quantum entangled. However, the information conservation principle of quantum mechanics requires that an early emitted Hawking radiation particle A may become quantum entangled with a later emitted Hawking radiation particle C. And here comes the contradiction. A is entangled with B, and A is also entangled with C. This violates the monogamy of quantum entanglement. Simply put, quantum entanglement must be monogamous. No third party allowed. Therefore, particle A can be entangled with only one of them. The root of this paradox lies in three principles: the equivalence principle of general relativity, information conservation in quantum mechanics, and the monogamy of quantum entanglement. These three conditions cannot all be true at the same time. One of them must die. So far, more than 3,000 academic papers have explored this paradox. The simplest proposed solution is to abandon the equivalence principle of general relativity, and allow particle A outside the black hole to break its quantum entanglement with particle B inside the black hole. When A and B break their entanglement, a huge amount of energy is released, forming a ring of extremely high-energy radiation near the event horizon. This is where the name black hole firewall paradox comes from. Compared to these, the black hole information paradox and the firewall paradox are relatively minor problems. The real killer is the black hole singularity problem. This is the greatest challenge black holes pose to modern physics. All the mass of a black hole is concentrated at its center, at a point called the singularity. At the singularity, volume is zero, density is infinite, and curvature is infinite. But physics has an unwritten rule: no physical quantity is allowed to be infinite. Once infinity appears, it means the theory is broken and needs to be revised. In fact, there are 5 Nobel Prizes related to eliminating infinities in physics: 1965, 1979, 1982, 1999, and 2004. All 5 were awarded for removing infinities from theoretical frameworks. The fact that 5 Nobel Prizes are related to eliminating infinities shows how much physics hates infinity. Infinity is a mathematical concept. Nothing infinite exists in the real world. Therefore, no physical theory should contain infinities. So what exactly is infinity? Mathematicians have been divided into 2 opposing camps for more than 2,000 years: actual infinity and potential infinity. Actual infinity claims that infinity is a completed, existing entity. Potential infinity claims that infinity is only an ongoing, never finished process. For example, actual infinity says the universe is already infinite in size. Potential infinity says the universe is currently finite, but is continuously approaching infinity. Here are some examples. An infinitely long line exists. A set containing infinitely many points exists. A set containing all natural numbers exists. Actual infinity says these things exist. Potential infinity says they do not. To summarize briefly, actual infinity is like the past perfect tense in English. It treats infinity as already completed, static, and real. Potential infinity is like the present continuous tense. Infinity is dynamic and only potentially existing. Which side do you agree with? Tell me your answer in the comments or bullet chat. The ZFC axiom system is the deepest foundational framework of modern mathematics. There is nothing more fundamental than it. More than 99% of modern mathematics is built on the ZFC axioms. The ZFC system contains 9 axioms, one of which is called the axiom of infinity. This axiom treats infinite sets as completed entities. Therefore, the entire modern mathematical framework is built on actual infinity. This sentence is very important, so I'll say it again. Modern mathematics is built on actual infinity. But in the real universe, does an infinitely long line truly exist? Does a line segment really contain infinitely many points? Is the universe already infinite in size? Obviously, actual infinity looks more like an idealized approximation of reality. That is why many thinkers opposed actual infinity and supported potential infinity, including Aristotle, Galileo, Newton, Leibniz, Spinoza, Gauss, Poincaré, half of Hilbert, Weyl, and others. Gauss once said, "I protest against the use of infinite magnitude as something completed, which is never permissible in mathematics." Poincaré said, "Actual infinity does not belong to science, but to theology." And he suggested replacing actual infinity with primitive recursive functions. Physical equations are written in the language of mathematics. Since modern mathematics is built on actual infinity, physical equations already implicitly contain actual infinity. Let's give 2 examples. Quantum mechanics is built on Hilbert space. And Hilbert space is an infinite-dimensional linear space. Therefore, quantum mechanics implicitly contains actual infinity. General relativity is built on Riemannian geometry. Riemannian geometry requires spacetime to be continuous and smooth, and the concept of continuity and smoothness can only be defined using actual infinity. Therefore, the equations of general relativity also implicitly contain actual infinity. Thus, physical equations already embed actual infinity. This may be the fundamental reason why quantum mechanics and relativity produce infinities. At black hole singularities, 100 years ago, Riemann abandoned the parallel postulate and created Riemannian geometry. Einstein used Riemannian geometry to build general relativity. By the same logic, if mathematicians were to abandon the axiom of infinity and develop a new mathematical framework, perhaps black hole singularities would no longer produce infinities. Therefore, I personally believe that the black hole singularity problem is largely the mathematicians' fault. Mathematicians have not yet invented mathematical tools that can properly handle black hole singularities. Let's summarize briefly. Actual infinity, the axiom of infinity, the ZFC system, modern mathematics, quantum mechanics, and relativity equations all lead to infinities at the center of black holes, and thus we identify the root cause of black hole singularities: actual infinity. Besides actual infinity, there is another contributing factor, the point-particle assumption. What is the point-particle assumption? Physics assumes that fundamental particles, electrons, quarks, photons, are dimensionless points with 0 size, 0 length, and 0 volume. String theory abandons the point-particle assumption, and instead treats fundamental particles as one-dimensional strings with length. Loop quantum gravity approaches the problem from the perspective of potential infinity, making time and space no longer continuous. String theory eliminates the point-particle assumption. Loop quantum gravity eliminates actual infinity. These two, string theory and loop quantum gravity, are currently the two most mainstream approaches to quantum gravity. Finally, let's talk about confidence levels. Black holes have enormous mass and extremely small volume. Light cannot escape them. They have accretion disks and relativistic jets at their poles. All of these phenomena are supported by abundant observational evidence, so their confidence level is extremely high, probably above 99%. However, the deeper we go into a black hole, the lower the confidence becomes. Near the event horizon, the most reliable current view is that black holes do not have a hard surface. The reason is that if a solid surface existed, gravitational wave echoes would appear during black hole mergers. Astronomers have not detected such echoes, so the mainstream view is that there is no hard surface near the event horizon. Other theories near the event horizon, such as Hawking radiation details, firewall hypotheses, fuzzballs, and so on, have no observational evidence, so their confidence levels are very low. As for what happens inside a black hole, things become even more speculative. Everything there is a mathematical toy model. Time becomes space. Space becomes time. Two black holes connect through a wormhole. Or the interior is filled with microscopic strings forming a fuzzy ball. All of these lack empirical evidence, and often contradict each other. Therefore, their confidence level is extremely low. Finally, let's discuss a philosophical question related to black holes. The event horizon of a black hole forms an information barrier. No information from inside can be transmitted outward. Suppose you marry the person you love most inside a black hole, and want to inform your family back on Earth. There is absolutely no way to transmit the information that you got married. The black hole's event horizon is an information barrier that blocks all internal information. This means the interior of a black hole is an unknowable region. You may imagine that another universe exists inside a black hole. You may imagine that a group of ultramen live inside it. Science can only describe observable phenomena. It cannot judge the truth of unobservable ones. Since the interior of a black hole is unobservable, the scientific method fails when confronted with it. Information barriers like the black hole event horizon may represent the ceiling of scientific capability, the inherent limitation of science as a methodology. Therefore, science has no ability to reach ultimate truth. The end of science must be agnosticism. This perfectly echoes Kant's statement. The thing in itself is unknowable.